can. So here's what I want to do today. We have a very interesting rocket launch that occurred on January 15th, and that was a Falcon Heavy that was launched from Cape Canaveral, Florida. And the thing that was interesting about it was that Astronomy and Live and I did an entire presentation on this rocket launch. And when I'm done with this, I'll go ahead and stick the link to that in the description. Or you can just go to my channel. It's the one that appears just before this one. Same thumbnail and everything. And the interesting thing about that rocket launch was that we had 3 cameras in addition to SpaceX. SpaceX was, of course, right at the Cape. Astronomy Live was about 14 miles away and videoed it as well. And then we had 2 other people videoing it. One was a gentleman by the name of Wide Awake, who apparently is a rather vehement flat earther because he's the guy that we're going to talk about today. But he was videoing that from Spring Hill, Florida, which is 115 miles essentially due west of Cape Kennedy. And then we had another gentleman up in Myrtle Beach that filmed it as well. And what we did was, Where's Wally down in Australia synced up all of these videos. And he synced them up based on when the boosters separated, and other visual clues that were in all 4 videos. And Astronomy Live pulled the data from the launch and synced it up according to when the engine started, for example, on the 2nd stage. And he synced it up and came up with essentially exactly the same thing, of course, because, well, the boosters come off at a certain time after the launch and they're visible in all of the videos. So the bottom line is that it took 36 to 40 seconds for that rocket to appear on the other side of Florida because it had to clear the horizon. And it took an additional 60 seconds, or a total of 96 seconds from the time of launch, for it to break the horizon in Myrtle Beach. And I recall as a child, I watched the launch of Apollo 17 from Sunrise, Florida, near Fort Lauderdale, about 153 miles south. And I remember it took forever for that rocket to become visible. But once it was visible, I mean, it was literally as big as my fist, the flame coming off of that. The other cool thing is that you can see the rocket itself in all of these videos, not just the flame, but the actual rocket. Now, obviously, this really caused some serious issues with flat earthers, because this is pretty much proof positive of a lot of things that they don't believe in. The Earth being a globe, the Earth rotating, the atmosphere not being contained by a dome. And I just wanted to kind of go over all of the different things that were in this video and the flat earth response. And I'm going to not so much address them simply from a scientific aspect. I'm going to show some of the techniques that they're using and the characteristics of science denial that they're exhibiting. So before we get started, let's go ahead and just double check the chat real quick. Looks like we've got 44 people watching. I'm not going to say hi to everybody individually because I kind of want to get going with this and make sure that we get a nice presentation, because like I said, I want to pull up those images from my telescope. It's running between 3 o'clock Eastern and 4 o'clock Eastern over in Spain, which is, I think, 8 to 9 p.m. And I'm very anxious to see whether or not I got my asteroid, because, you know, we've had such horrible weather here in Michigan that I haven't been able to get a telescope on it since I discovered it about 14 days ago. And every day that cloud of probability of where that thing is going to be just keeps getting larger and larger. And I want to really nail it down because it's kind of an important asteroid to find. So what I'm going to do here is I'm going to go ahead and pull up his video, and let's go see whether or not we can start going through it. So let's go ahead and just kind of get started from the beginning with this guy. Now, this is the guy that filmed from Spring Hill, Florida, which is 115 miles west of Cape Kennedy. Now, apparently, a lot of the globe supporters, as he calls them, are coming to his channel and saying, hey, well done. Thank you very much for proving the globe. And that kind of pissed him off, so he put out this video to try and explain this away. Very reminiscent of Bob, a 15 degree per hour drift, Nodell, thanks Bob, trying to explain away his expected finding on a globe, which he found, and now he had to come up with some other way of trying to demonstrate why it happened. So let's go ahead and have a listen to him and see some of the techniques that he's using. And this is pretty typical of the flat earth, so let's just have a listen and see what we got.
Okay, I'm making this video in reference to the globe trolls that have come on my last video of the rocket launch. And what they don't never take into consideration is the blockage that I'm getting from these trees and the horizon that's in front of me. Yes, I may be 85, 95 feet high, but there's a lot of land between me and the East Coast that is much higher than even where I'm setting. Because if you look at the terrain, the cartography between my position and the East Coast, there is pretty much 10, 20, maybe even 30 miles of my actual horizon being blocked from this tree line that's directly in front of me.
Okay, so his claim is that because he's got these trees between his position and Cape Kennedy, that the rocket is taking a full 30 seconds to go from the ground to the top of those trees. And, who knows? There could be 20, 30, 50, 75 miles missing. All right, well, that's not the way science works. What we do is we don't say who knows. What we do is we actually have a look. So let's go ahead and have a look and see what we have here. So we've got Google Earth. Let's go ahead and make this big. Come on. All right. So what I've done here is I've gone ahead and put a line between the launch pad for the rocket, which is here at Cape Kennedy, and these are the two shuttle pads right here. The southern one is leased by SpaceX, and that's where this rocket took off from. And then what I did was I actually went over and I found his position in Florida here, and here we go. So where was he? Well, he was right here by this shopping mall, and he was on this little hill right here. Now, if you look with my little hand or pointer right at his location, if you look down in the corner, that's 95 feet above sea level. All right. Now, let's go ahead and have a look down his line of sight. So where are those trees? Okay. Those trees, there's no trees here, are probably these trees out in this general area right here. Now, the interesting thing about this is that this is also at approximately 95 feet. So how tall are those trees? Well, I went down and had a look at them on Google Earth, and based on the size of the buildings, those trees are probably between 50 and 60 feet high. So let's go ahead and pull up a right triangle calculator. So we're going to stick this over here and just kind of pull this up real quick. So here's our right triangle. So the distance from C to A is going to be the distance from our friend's position and that line of trees. And that is about 0.64 miles. So let's go ahead and find out what that is. So we're looking at about 3,380 feet. So let's go ahead and we're going to stick that in our triangle calculator. So that will be side B, 3,380 feet. Now, what about side A? Let's go ahead and use 60 feet for that, because that's the approximate size of the trees. And what we want to do is we want to find this number right here, and that is angle alpha. Now, other people have done this. So Cinnamon Control, I think, did a video on this too, or did some work, and he agrees that it's about 1 kilometer to those trees, because I think he's looked at them as well. So his numbers are actually coming up very nicely with mine. So if we go ahead and do this, all right, this thing right here says it's 1.017 degrees. Now let's go ahead and change. Let's leave that as the number. Give me a second to write that down. I'm doing this live, by the way, so let's go see what that is over on the other coast of Florida. So we're going to go back here. Let's see if we can get back, or we have to redo it. No, we got to redo it. So what we're going to do here is we're going to use leg B is going to be the distance from his position to the launch pad. Now, I've already looked at that. I've already looked that up. And it's quite a long ways. It's 607,200 feet. And our angle, which we just got, is going to be 1.017. And let's solve for side A. All right. So according to this, we've got about 10,000 feet. Okay. However, is that really the amount of blockage there is? Let's go ahead and have a look at the video again and see where we actually see the rocket appear. Boom. There we go. So what I'm going to do is I'm going to go ahead and advance this a little bit. Very carefully. Okay, so right here is where that rocket is. Look at that. It's below the tree line. See that? That's kind of a very interesting point. So it didn't quite make it up that far. Now, the other thing that we need to do is we need to go ahead and have a look at his measurements of where he thinks this is going to be. He cut it out. Because what he did was he actually put up the he put up a level next to it. And that level pointed into the actual tree line. But the bottom line is that the Falcon Heavy did not have to wait until it had cleared that tree line before we saw it. Okay? Now, as you recall from my video, how high was that rocket when we first saw it from Myrtle Beach? Okay, so it's 890 meters, almost 1,000 meters. That's when we first started to see the rocket from Spring Hill, which is considerably lower than 10,000 feet. Now, that kind of invalidates his entire argument right there, because we saw it before he said we should have seen it based on the blockage of the trees. Now, there's another interesting thing that we had going on with this as well, and that is his next quote in the video.
Some kind of
See how much lower the
bug
rocket was seen down in here?
floating around in the air. Just look at the size of this. Zoomed in on it. Yeah, that's the. If
Now,
you really believe that this thing is going to take up a sense is not obvious, common, because most people don't have any common sense. They say it's to 30 seconds for this rocket to appear in my visual line of sight above
Okay.
these tree lines.
Okay.
Now, for you globe people to think otherwise and just kind of come on my channel and say, oh, you just proved the globe with your rocket launch. Again, you guys are idiots. You
Yeah,
guys
we're
ought
all
to
idiots.
rethink your whole um, attack on us flat earthers because it ain't working. Because most of us already know that you guys are just believers. You believe the government. You trust the
Well,
government.
we're gonna let
I,
his
and then they
paranoid
start the
rants.
countdown, and I'm going. So again, I'm not looking out across the ocean. I am looking out across a lot of terrain.
Okay, so here's the key thing that I want to mention with that. He says that he's not looking out across the ocean. Well, unfortunately, the guy in Myrtle Beach was looking out across the ocean. And as a result of that, he was able to actually see it come right off the ocean. And we're going to have a quick look at that real quick, and we'll see whether or not there's any terrain in the way between our view in Myrtle Beach and the ocean. So we're going to pull that up real quick. So here is the original video that I put out right here. We're going to make that big on the screen. Now, here's the interesting thing about it. If you look very carefully, you can actually see when, okay, here's a minute 5. So we're going to go on up here. And here's a minute 29. Let's go ahead and play it because this comes up right about here, as I recall. And it's at about a minute 35 to minute 36 seconds. There it is right there. See? Now, what I'm going to do is I'm going to go ahead and just make this a little bit larger so that you can see it. You see the rocket coming up right there? Let's go ahead and play it a little bit more so you can see that that is actually the rocket. See the rocket coming up? And then what he does is he shifts it over a little bit so that it's a little better centered. But you can clearly see that rocket coming up. And at that time, the rocket was approximately 23.1 kilometers up. There are no trees in between. So we can actually disregard this entire argument that he is making for the simple reason reality doesn't bear it out. Both of these observations are exactly in line with the Earth curve calculator. But there are actually some other things on this video that I want to go over now that we didn't really talk about in the other video. First of all, it's this shot right here. Let's go ahead and back it up a little bit. I want you to have a look at this image that he took. You notice the kind of orange-yellow light here on top? And then down at the base of the, at the tree line right here, you kind of see a pinkish area. This is called the belt or the girdle of Venus. And this is the anti-twilight arch. Now let's go ahead and advance this a little bit and see if we can get a little better shot of it. Now, right here, you'll notice that there is some purplish area down over by the tree line. There is the bright sky above it. And in between is this pink layer of the belt of Venus. Now, here is sunlit sky. Here is twilight. And underneath it is the shadow of the Earth. All right? This purplish area right here is the shadow of the Earth. Now, here's the important thing that you should look at with this. Let's go to the other end of the rocket launch, which I might add is only about 5 to 10 minutes later. Now, as the rocket's coming down, the boosters are coming down, have a look at the belt of Venus right there. Notice anything different about the shadow of the Earth? You see how much higher it has come? That's a great indirect demonstration of the rotation of the Earth. What that clearly demonstrates is the fact that the sun is below the horizon to the west behind the viewer. Okay, so let's go and check the chat real quick, and then we'll go on to the next thing. No trees over the ocean, that's absolutely right. Yeah, so every argument that he made that the trees were somehow blocking a view of the rocket taking off from Cape Kennedy 115 miles away is absolutely ruled out by the fact that the exact same effect occurs from Myrtle Beach where there are no trees. Now, there was drone footage from Palm Bay, Florida, as I recall. I think Red's Rhetoric took that, and he did have that drone up about 400 feet in the air. The rocket had to get at least 1,000 meters in the air before he could see it, and they also had some from Bethesda, Maryland, as I recall. Bethesda or Annapolis, Maryland, one of the two. But right here is the anti-twilight arch, and this is a very good demonstration that you can see anytime the sun rises or sets from any location on Earth. All you have to do is wherever the sun is, if it rises in the east or it's setting in the west, you look the opposite direction and you will see the belt of Venus. I've gotten a number of shots of it myself. Now, another thing that we have to have a look at on this video, which is very telling, is the rocket plume itself. Now, right here, you can pretty clearly see the rocket plume. Let's see if we can get a shot here. Okay, so that shot's got the rocket in it as well. Now, remember, this is from 115 miles away. Notice the shape of this rocket plume. You see how it's long and pencil-shaped? Let's go ahead and come back a little bit later. How about when we start getting out in here? Look at that. You see how the rocket plume has spread out quite a bit? That has to do with the ambient air pressure around it. Now, as the rocket plume comes down, the ambient air pressure compresses it. As that pressure drops down, as you go higher in the atmosphere, that rocket plume will begin to spread out and out and out, and eventually it'll spread out so far that you can't even see it anymore. Now, in some cases, these things here are, the rocket engine is shut off, but in something like this, where the boosters are separating out, you can definitely see how wide that rocket plume has become. And one thing that Astronomy Live brought up was the change in the color of the smoke. Because there's so little oxygen up at that rarefied atmosphere, you have incomplete combustion of the exhaust. Granted, they put oxidizer in it, but you still get some incomplete combustion of the exhaust, and the smoke turns from bright red and black to this gray color. And that's pretty obvious in a lot of the other videos that you can see from the other locations. Again, go ahead and have a look. Go ahead and have a look at the video that Astronomy Live and I did, where we go over all of these things as well. But these are just some things that I wanted to point out that are nice, clear-cut demonstrations of the things that they claim aren't occurring, such as they claim that the rockets don't go into the upper atmosphere, they just go up and down. That rocket is still going up. And you can easily tell that in a lot of these videos. For example, when I went ahead and had a look at the launches themselves, let me pull that up again. You can clearly see this from the Myrtle Beach cameras. So let's go ahead and pull that up real fast. Now, what I'm going to do is I'm going to bring this down here. But I want to bring this on out a little bit more. Okay, so here's Myrtle Beach. Now notice the widening of the rocket plume. Let's go a little bit further on out. See that rocket a little higher in the sky in Myrtle Beach is what I want. Notice how wide these rocket plumes are right here. You see how they're spreading out into almost a teardrop-like shape? Now that completely goes against their argument that the rocket goes up and down. That rocket is clearly still going up. Now the other issue that you're running into is the sky color. And that is There is a big difference, as you can see here, between the Astronomy Live over on the east coast of Florida and SpaceX, which is on the left side here. And on the upper right, this is Wide Awake over by the Tampa area. You notice the sky is still much lighter. And in Myrtle Beach, South Carolina, which is also over towards the east coast of Florida, it's actually a little further than the east coast of Florida. Look how dark the sky is still. But the contrails are starting to pick up light from the sun. And that's the same effect that causes the anti-twilight arch or the belt of Venus. Remember, the upper sky was very light. This is still daylight up here. Here's the twilight, and here is the shadow of the Earth, which is elevating as the Earth rotates towards it. Now, let's go ahead and have a look and see if we've got anything going on in the chat. Now, in my original video, what I did was I absolutely went through all of the curve calculations. And here is another objection that I heard, and that had to do primarily with this rocket appearing in Myrtle Beach. Now, let's go ahead and just have a real quick look at that. Now, this is probably the silliest of all of the ones that I've seen. Right here. So when that rocket appears in Myrtle Beach, so here's the rocket in Myrtle Beach. The rocket in Myrtle Beach appeared when the rocket was 23.1 kilometers high. And we did the curve calculators on it, and that works out exactly as would be expected on the spherical Earth of radius 3959. Now, I was hanging out on one of the Flat Earth Discord chats the other day, and their argument was, well, have I proven that refraction bends light downwards? No, I haven't, because I don't need to. Here's the way science works, and this is something that they really don't get very well when they're dealing with the flat Earth, and that is that I don't need to go back and prove every single step of my premise or my hypothesis. I can have certain things that are given. So, for example, given the Earth being a spherical planet of radius 3959 miles, and given that refraction follows Snell's law, on the surface of the Earth, light will bend downwards, causing objects to appear higher than they actually are on my vision. Now, that radius of that curve of refraction is generally given as 7/6 times the radius of the Earth. I don't need to demonstrate what the radius of the Earth is. I can substitute 7/6 times 3959 and get the exact same curve. And that is part of my hypothesis that if the Earth is a sphere of radius 3959, and given standard refraction in the atmosphere, I will see that rocket from Myrtle Beach 1 minute 36 to 1 minute 40 seconds. Now, if indeed I do see that rocket at 1 minute 36 to 40 seconds, that verifies the validity of my hypothesis. Now, if they wish to question that, they have to demonstrate under what condition light would not bend downward, but would in fact bend upward, or try and demonstrate that light won't bend at all, despite the difference in the temperature of the ocean versus the temperature of the air. By the mere fact that the reality of my observations of reality followed my prediction, and my prediction had a known mechanism that has been validated many times, standard refraction, I don't need to demonstrate conclusively that the light didn't bend upward. They have to demonstrate that the light did not bend downward, as would be predicted by standard science. So that argument is simply being ignored by me. I'm not going to sit down and reprove refraction for them. If they want to learn about refraction, they can learn elsewhere. The bottom line is, by putting standard refraction and the known distance between the rocket and the observer, you can clearly predict when that rocket will appear over the horizon, be it over trees or be it over water. And when it does that, that validates your prediction. And by validating your prediction, you're validating your hypothesis. Now, the difference between a hypothesis and a story, or something that is made up, is you demonstrate a valid reason as to why you believe the hypothesis is correct. Then you assume it is correct, make a prediction based on it, and then test that prediction against reality. That was what was done here. I'm not making a prediction that this is God or unicorn farts or whatever it is the flat earth likes to make analogous to coming up with a hypothesis. It's not a random story that we came up with. We had a very valid reason for doing this, and that we can test that reason in a number of different ways. We have done so. We validated the curve of the earth at 3959 from the west coast of Florida and from Myrtle Beach. Others did it from Palm Bay and Annapolis. Now, I did this when I was 10 years old and realized this by watching Apollo 17 go up and realizing that it took a good 40 to 60 seconds to clear the horizon through trees to my house down in Sunrise, Florida, 153 miles south of Cape Kennedy. But you could clearly see it. You can't accept an argument that, well, how can you possibly see a rocket that far? We just demonstrated it. There it is. And we measured the distance based on the telemetry. The other thing I think was probably the stupidest thing that I heard was that when the rocket was below the horizon in Myrtle Beach, they tried to say, well, is the rocket on the ground or in the air? If it's in the air, well, you have to look at it visually, and that's only an apparent location of the rocket because of, refraction. And then turn around and argue against refraction. You can't have it both ways, kids. We know the height of the rocket based on the telemetry. We took into account standard refraction. The rocket appeared when we said it should. So I don't have anything else to add on that. I think that we got all of the cool little things in addition to the timing of this, but we talked about the belt of Venus. We talked about the rocket plumes. The compression argument is, again, rather absurd. One of the biggest problems that he runs into with this entire silliness by claiming compression or blockage of the trees is this. Okay, so here's his video. Let's go ahead and just make that nice and large so it looks good. Now, what he's claiming is that it took the rocket. Here is the approximate horizon. No, actually, when he did his measurements with the level, he was saying basically this would have been his horizon right here, because he was up at some 96 feet as well. And these trees, some of them are on ground that's 50 feet above sea level. Some of them go up to 105. So you can't really sit down and say that these don't play a role. They do. But you also can't say that you don't see that rocket that came up about where the cursor is right now. Okay? It came up through the trees. You didn't even have to wait until it was all the way up. And we could find a timing. So let's just go ahead and do that. Okay, so right here, let's go ahead and see. So right there is when it first starts. Now notice that we've got a little bit of tree line above it. Let's see how long it takes to go that distance. So that is 7:18. And it cleared that tree 2 seconds later. Now, that took 2 seconds to go from there to there. How long did it take to go from there down to here? Does he honestly believe that suddenly it was 30 seconds to go this distance from here to here, and then only 2 seconds to go from that distance from there to that? Now, granted, the rocket does start off a little bit slower You know, it starts from a standstill. But did it take 30 seconds to accelerate from here to here, yet only 2 seconds to accelerate from there to there? It's just, that's just an untenable claim. So again, we're dealing with curvature of the Earth, and it follows exactly with curvature of the Earth. So yeah, there's a lot of math involved in science, Gigi. And I do a lot of it with Astronomy Live in the other video. And given that, I'm just going to sit down and say that the math has been done. You're welcome to look at it. And we're taking that as a premise right now that the math was done. And how do we know that it was done? Because I did it right here. Here's where all the math was done. If you want to review it all, feel free. All the math was done right here. So I don't accept any claim that the math was done, Gary. Now, if you don't like it, go back and look at the video and review the math yourself. It's as simple as that. All right. So I think that's probably about all I want to do right now. It's been about an hour. I want to go check my images on my asteroid.